Hey, today on the On.net show, we're going to be talking about System.Threading.Channels with Steve and Toub. Come check it out. Hey, welcome to another episode of the On.net show. Today we're going to be talking about System.Threading.Channels with Steve and Toub. Hey, Steven.
Hi, Rich.
Yeah, it's been a while since you've been on the show.
It's been a long time.
So we're going to be talking about channels. This is a feature that you built, probably in concert with some other folks. And what version of the product did this first ship with?
It's available as a NuGet package. It shipped around .NET Core 2.1-ish timeframe, and then it's also in the box in .NET Core.
Yeah, cool.
Yeah.
And so out to the 10,000 foot level or 1 kilometer level, what would you say this is for?
Sure. So a channel it's actually a very simple mechanism, and the whole purpose of it is to hand off data from one party to another. If you think about a collection like list of T, or queue or stack or whatever, you put data in, you take data out. And the only thing effectively that channel layers on top of that is the synchronization and the coordination necessary to hand that data from one party to another. It is a producer-consumer collection, essentially. In fact, if you're open to it, the easiest way to demonstrate it might be actually just implement like a 10-line one quickly.
Yeah, that sounds great. More than open to it.
That can sort of set the understanding for what this is, and we can go from there.
Yeah, great.
I'm not yet, I've brought in the System.Threading.Channels namespace, but I'm not yet going to use it.
Yeah, and that's why it's great.
That's why it's great. So we're going to implement our own. So let's say I just define a type called my channel. We need basically two things. We need the storage and the coordination. So,
right, and then right now you're not channelized. This is just a POCO.
It's just, yep. So I'm going to add a type. I'm going to add a member here. This is a concurrent queue. So this is a queue that I can access for multiple threads concurrently.
Right, so this is basically your backing store.
Exactly. Concurrent queue. And then I'm going to add the synchronization to coordinate the interaction between the two players. Concurrent queue is thread safe, but you have no idea when I add something to the queue, you don't know when it's there. So you need to be able to be notified. So I'm going to add a semaphore slim. And now we just need we're going to add two methods to operate on this. We're going to add a method to write and a method to read. So I'm going to add a write method that takes an item. And because I've sort of implemented this in an unbounded fashion, there's no limit to how much I want to be able to put in here. My write method is just a synchronous synchronous method, because it's always going to succeed subject to memory limitations.
Yeah, and we're not worried about that.
And we're not worried about that. So then my read method is going to return a task of T, and it's going to be async, because we might come and there might not be anything in this in the collection, so we have to wait, and we want to wait without blocking the current thread.
I see. So that's a policy that you don't return a bool, for example. You basically say, I will always return something, and in absence of something, I will wait till it's available.
Exactly, and that's a choice that I'm making right now.
Right, so it doesn't have to be that way.
That doesn't have to be that way. And in fact, we'll see with the actual channels, you have the option of your consumption model.
Right, and you didn't, I think, explicitly say this, but I think what you're doing right now is this is the homegrown version that you're doing. So this isn't, people at home that want to adopt channels shouldn't actually be writing this.
You're not going to write this code. I'm using this to sort of exemplify the core concept that is a channel. The implementation that we have in .NET effectively does the same thing, but in a more efficient, more robust, more functionality manner.
And way more lines of code.
And way more lines of code.
Yeah.
Yeah. So now our implementation is going to just require basically 4 lines of code. So in order to write, we need to put the data into the queue. So we add it, and then we need to notify anyone who's waiting that there's something here. And to do that, we'll release on the semaphore, which basically says if anyone's waiting on this, there's something that you can go check out.
And now help me understand. So I definitely have heard about semaphore slim many times. I actually haven't used it. I've used things like monitor. So what is, before you hit release, what was the state that it was in before?
So
is that the zero
That's what
thing?
the 0 is here. So the semaphore has an initial count. And that basically says, if you think of it as a box of keys, if you want to be able to use the bathroom that requires the key, right, you need to grab a key out of the box. If there are no keys in the box, you have to wait for the key before you get it to go and use the bathroom. By creating the semaphore with 0 keys in it, if anyone walks up to that box, they're going to have to sit there and twiddle their thumbs waiting for a key.
And that's kind of the read async thing.
And that's the read async thing. And the release is putting a key into the box.
Oh, okay.
On the read side, I need to wait for a key. So I'm going to say await sem.wait async. At the moment I get past here, I now have a key in my hand. At which point I know that because the only reason a key was put into the box is because there was something put into the queue, I can do q.tryDQ out t item and return item.
Right. So is it fair to say this is kind of almost the opposite of like the, addref release kind of, like in that type of release, it's like I'm basically saying I'm like giving up this memory. In this wording, it makes it sound like I am giving something, I'm releasing this to the semaphore slim for it to represent it.
It's exactly the same concept.
Yeah.
Yep. And that's it. We've got our channel. So now we can use this thing. So up here, I'm going to create a producer of data. So I'm going to spawn a task that's just going to sit in an infinite loop. It's going to wait for, say, a second. And then it's going to put some data into my channel. So here I'll say new my channel int. And I will do c.write of my I. And so I'm just sitting here in an infinite loop, putting data in. Once a second, it's going to add an item. And then down here, I'm going to sit in the loop. And I'm going to say console.writeLine await c.readAsync to read out, wait for data to be available, and when it is, read it out. Right?
Makes sense. And should I think of this task.run as running on another thread?
You can think of it that way.
So as more put it a different way, have you so you said that this mechanism that you've just created is thread safe. Should we think of this particular code as requiring that thread safety, or this does? It
does require that thread safety.
Yeah.
So if you forget the async for a moment, we could do this without async. If we didn't have all this async stuff in here, we spawn a task. The whole body of this task.run is going to be sitting on some thread pool thread, either blocking, waiting for a period of time, or accessing the channel to put data into it. And concurrently, we'd be sitting here in our loop pulling data out of the channel. So they'd be concurrently accessing.
Yeah, exactly.
My only hesitancy with your comment about the threads is because we are using async, the only time we're actually executing on a thread is this period of time where we call write, loop around, and then hit the task.delay. Once we hit the task.delay, we then get off that thread, and we're in a callback model that the compiler is sort of putting up in here. So we can run this, and we will see that once a second, it starts, the producer wakes up, spits out a number, the consumer wakes up, reads it, and off we go.
Right, and because they're, actually, I don't remember what the console write line was representing. It's just
taking the data out of the
count.
Yep.
Okay.
So this guy is just putting data in, and he's writing out whatever he got.
Oh, I see. Now I understand.
Yep.
Yeah, you were writing in I.
Exactly.
That's why it's going up.
That's why it's going up.
Yes.
Yeah. And so, fundamentally, that's what a channel is. Now, System.Threading.Channels means we don't actually have to write this my channel class. So I'm just going to go down here and delete this. I've got my namespace here, and instead of saying new my channel, I'm going to say channel.create unbounded. We created an unbounded channel before, meaning there's no limit on how many things I could put in.
So it's basically policy free.
Exactly. And then there isn't actually a write method, but there is a writer.tryWrite. And there isn't actually a read async, but there is a reader.readAsync.
And what's the try guarding for in this particular case?
So in this particular case, I don't need to do anything with the try because the write will always complete. It'll always return true.
I see. It's because it's the same API for both bounded and unbounded scenarios?
There are many different possible channels, concrete implementations of a channel one might have. And so to be accommodating, there is a try-write method. We could have also had said await cwriter.write async. And now, just like the reader waiting until something is available, the writer will wait till there's space available. In the case of the unbounded collection, this will complete synchronously. In the case of a bounded collection, this will wait until there's space available for the data to be written.
I see. Is that where we get into tasks and value tasks?
It is.
Well, one more question, which is, in the try pattern, we often have this, like, it returns a bool and that kind of thing.
That exists on the reader side. So in the writer side, there's nothing to return. But on the reader side, you can say try read, and it's exactly what you just said. It returns a bool, and it outs the int.
I see. So why am I confused? So wasn't there a try there before?
Oh, yeah, I changed it.
Okay.
Just as part of the example. So this was try write.
Okay, that's why I got confused.
Yeah.
So does that returns void?
This returns bool.
Okay, it does.
But there's no
void.
Out.
But
it's sort of the corollary with the try read, which has an out.
Totally get it.
Yeah.
Okay.
And so this is fundamentally the channels. We can run, do the exact same thing we did earlier, and we're getting the exact same output we saw earlier because it's doing fundamentally the same thing.
Now, this might not be a useful question, but is there any value? So you showed us the code before. It was super simple, straightforward. Is there any value for this super simple scenario that you got by moving to channels, other than that you didn't have to write and maintain that code?
There is. So first, you didn't have to write and maintain the code, which is a big one. Second, the implementation here is much more efficient than the one that I showed earlier.
Okay.
And in particular, the write side, the writing that I showed earlier was fine. But the reading that I showed earlier, it was going to be allocating a new task for every piece of data that handed back, even if the data was already available. Because we don't store 4 billion possible tasks for every possible integer in the system. So even if the data is available synchronously, for the most part, you end up creating a new task to hand back that data. This implementation, if you can read the fine print, doesn't return a task, it returns a value task. This not only allows for avoiding allocations when completing synchronously, but a lot of the code that you mentioned going into channels is this will avoid allocations even when completing asynchronously. So you can do this producer-consumer model and get a very efficient, very low allocation handoff by using this library. This library then also allows you to use the same kind of consumption code, or using the API while changing the semantics of the employed channels. So here, instead, I could say I want to create a bounded one, and I want to only allow one item at a time. Now, when this, I'm going to put this back to write async. When this tries to write, if the consumer hasn't yet picked up the data, it will wait for space to be available. So now, if I wanted to, I could put a task.delay here, an even longer one. And previously, without this being bounded, this producer would have just kept filling up the collection. There'd be no back pressure. Now there will be back pressure, so until the reader picks off the next item, this will end up waiting for space to be available. And we can run that as well, and we'll see now that every 2 seconds we'll see the next number printed out, and we're not growing our memory significantly.
Right, so I definitely have heard people talking about back pressure before, especially when you guys joined our team.
Back pressure is just the idea that if you have a producer that's running full speed ahead, generating a lot of stuff, and you're not consuming it as very quickly, it's going to build up a whole lot of stuff, and you want to slow me down.
Yeah, exactly. So do you think, or is it fair to say that this system has some useful back pressure kind of strategies with it, such that I guess you don't necessarily have to implement those other than use these? And is there a point where there are some really sophisticated back pressure strategies that you're aware of that then people could build on top of this?
Sure. So this has some pretty simplistic bounding strategies employed. right out of the box with this create bounded method, you can specify the number of items that you want to allow to be stored. And you can specify with some options various things, including what do you want to have happen when it's full. There are various policies you can imagine being employed. One is, if it's full, I just want you to wait. Another is, if it's full, I want you to drop one of the items that's already in there. And if you drop one of the items in there, which one? Do you want to drop the oldest? Do you want to drop the newest? Do you want to pretend that I took what you gave me and just drop it on the floor immediately? So those sorts of policies are built in, but there are certainly more complicated ones one might like. For example, let's say we just did the simple, I want to only allow 10 items into this collection. We fill it up, and now we're waiting. Now if a space becomes available, we could wake up immediately, and that's what we will do. Or we could say, you know what, that's kind of inefficient, because we're going to be ping-ponging back and forth between awake and sleep and awake and sleep. So maybe what we want to do is actually wait for sort of a low water mark. Wait, if we hit the bound, then wait for 5 items to be taken out, and only then wake up so that we can refill all 5 and then go back to sleep. That policy isn't currently built in, but we could add it in the future. Or because this is just returning channel of T, which is an abstract class, someone
can build
their own.
Yeah, it's funny. This reminds me a fair bit of, there was a developer who built these task combinators that offered different policies. You might know this developer.
Maybe?
Yeah, it's reminiscent of that, because it's basically this, I guess, low-level architecture, for lack of a better term, but then it's like there's a way that you want to interact with the things in the system, and there's like affordance for both policies that come with the system that you can use and also ones that you can build on top.
Exactly.
So it reminds me of task.whenAll or when all?
When any, yeah.
It reminds me of that. But yes,
and
you're the one who built those.
Yeah. The various modes of consumption that you talked about, we tried to design the channel API to be very simple but accommodate the various schemes that someone might want. So if you look at what APIs are actually available from the writer, there are basically 3 primary ways of getting data into the writer. You can try write, which we saw earlier. That would say that is synchronous. It will either complete immediately and return true, or complete immediately and return false and not have added the data. You can write async, which means we're going to wait until the data is accepted by the channel. Or you can actually tell the channel to notify you when space is available. So we can say wait to write async, and we will then be able to proceed when space is available. Now, if you had multiple writers writing to the channel, you might have a race condition. You might both wake up, they might beat you to it, and then you have to wait again. But you end up with typical loops, like you can say while await c.writer.wait to write async. If c. Writer.try write do whatever, otherwise loop back around and try and write again.
Makes sense.
Similarly, on the consumer side, let's go back to what I had. On the consumer side, there are various modes of interacting with the reader. We can, and there are parallels here. We can try read, we can wait to read async, and we can read async. Also, with the new iasync enumerable support that we added in .NET Core 3.0, you can actually just use language syntax and the await for each construct to loop over all the data items that are coming into the channel. So I can say, rather than this while true loop here, I can say await for each int item in c.reader.read all async. And now I am just sitting in an await loop here, pulling the next item out of the collection. I don't have to write my while loop. I don't have to say reader.read read async. It's just giving me the next item each time.
I see.
And
that makes sense.
Enumerables sort of naturally have an end, right? You get all the data and then there's nothing else. And so we want to enable this loop to wake up when there's no more data. When the writer says, you know what, I'm done. So the writer side, let's say we had I is less than 10. The writer await c.writer.write async I, and just We'll just make this a little bit faster. And then when he's done, the writer is going to say writer.complete, which tells the channel no more data is going to be added to you. If anyone's waiting for data, let them know that it's never going to arrive.
Right, so then the move next bool false is what comes at that point.
And now here, we'll say console write line done.
I get it.
And when we run this, we quickly output the 10 items, and we're done.
Sweet.
And you can do the same thing without the read all async. You can say,
that's a nice system.
Yeah, you can say, while await c.reader.move next, .wait for next rather, and then console dot. Well, I'll just do console.writeLine await c.reader read async. We could do that too, and because there's only one consumer right now, I don't have to worry about someone else taking my data. There are various modes of interacting this, but to your original point, they all stem back to what are the interaction models you expect with the channel, what kinds of channels do you expect to be using, and we try to provide APIs that allow you to interact with it in a way that meets your needs.
In the example we did, one producer, one consumer. It sounds like you can have an unbounded number of both.
You can. You can have any number of each, and the built-in channels are designed by default to accommodate any number of each.
Okay.
However, if you know that you only have a certain mode of operating, in order to support any number of each, we have to incur some additional expense.
I see.
So if you know that you don't need to deal with that, like maybe you're going to have one reader or one writer, you can set properties on this, and then we'll change the implementation under the covers to provide a more efficient one for that scenario.
Yeah, so this is a little bit like creating an array and setting the capacity up front. Or sorry, it's not an array, a collection.
Kind of. You're
Maybe
basically
that's a bad analog.
But you're making promises about how you're going to interact with it, and I can take those promises and then do better things as a result.
Yeah. Okay. So next question is, there's two kind of features that kind of got shipped from our team at approximately the same time, which were channels and pipelines. Yep. Abstractly, they seem to describe something very similar. Channels and pipelines are kind of both like cylinders.
Yeah, we had to come up with two different names. Yeah.
Yes. What is kind of like the merits of one and the merits of the other?
Yep. Pipelines is all about I/O. That is its bread and butter, and it's focused specifically on streams of bytes. It's much more aligned with System I/O stream, and it's very much focused on scenarios where you say, read a buffer of data off the network, process that buffer in some way, potentially just maybe parsing off some frame header data, and then handing that buffer along to the next stage in the pipeline, essentially. Channels is not focused on bytes. It's not necessarily limited to I/O. In fact, some of the initial uses of it aren't at all in the area of I/O. It's really about arbitrary handoff of data between two parties in the same process. It could be in Roslyn, for example. They effectively use a channel between, in their compilation server, a request arrives and they want to hand it off to the thing to actually do the compilation. We can use it in our HTTP2 implementation when we want to a request comes in and we want to hand it off to the main central processing unit to say, hey, a request has arrived, add this to your information. It's focused on any arbitrary handoff of data between two parties.
Makes sense. Now, everything you showed us was in process.
Yes.
Is there any place where you can use channels for cross-process coordination? You
absolutely could. The core abstraction of channel, if we just look at the definition here, it is just a class that exposes these channel of T-types. This is an abstract class that exposes a reader and a writer. The reader and the writer are themselves abstract classes. There's nothing in the abstraction itself that ties it to being in process. So anyone could implement these abstractions to go across any kind of inter-process, cross-machine, cross-network boundary. In the box, these create, on our static factory methods, they're only in process. It's just like saying, new list of T or such a collection.
Okay. So one of the models for programming a little bit more in the past was PubSub. You were talking about publisher-consumer, which is somewhat similar, but PubSub I think is slightly different. Could you use channels instead of PubSub, or would you see this as being something underneath PubSub?
You could use it as an abstraction on top of another PubSub implementation, and you could use it inside of a PubSub implementation. But because there isn't, there's a lot of other machinery that goes into PubSub, typically storing the information for later in some persistent database or whatever it may be, it wouldn't just be like pop a channel in there and be done. There's be a lot more implementation around it. But you could absolutely use it as part of it, and you could use it on top of it.
Okay. I guess maybe two more questions. One is there anything more coming in this domain, or we're pretty happy with how channels is and also pipelines at this point?
I mean, I think at the moment we're pretty happy with the core abstraction. We welcome, however, feedback on new APIs that would be useful to people. There are a couple suggestions currently pending in the .NET Runtime repo. We've added 1 or 2 additional methods in this release. One of the top pieces of feedback we got was people really wanted the ability to just inspect how many items were in there generally for telemetry. And so we added a count property. We're happy to do things like that. There's a pending request for, should we try peak? And we can certainly look at adding all kinds of functionality, but we want to be thoughtful about it in particular because it is an abstraction. We want to make sure it plays nicely with all potential uses.
Makes sense. Where should I look if I actually want to use this? So I'm convinced.
Okay.
You said this is in the product now, so it's definitely in 3.1.
Yep. So you can go to, if you want to look at the source, go right to the source. It's in the .NET Runtime repo on GitHub. There is a NuGet package if you want to use it with .NET Framework applications or wherever. If you say file new project in .NET Core, you'll have it available to you immediately. It'll just be one of the things that's automatically there because it's in the core framework, the shared framework. I actually wrote a blog post about it in November, December. So if you want to go up to the .NET blog, there's a lot of this stuff that we've just discussed shows up there as well if you want to recap.
Awesome. Well, this has been a pleasure as always.
Me too.
It's fun doing this when you're in town.
Thank you.
Okay. Well, folks, that was a pretty deep discussion of system threading channels from the channels expert, Steve and Toub. Thank you so much.
Thanks, Rich.